All right, we are live. So today, I thought let's do a live stream for the preparation of Speckle's hackathon. And I had done Speckle experiment about like connecting Excel, Rhino, and various basic experiment around 6 to 8 months ago. So this might be like second or third time I'm gonna use Speckle, but I thought let's prepare for the hackathon. If you are new watching this, what are some things which might be useful if you're getting started with Speckle? So I think they recently got funding as so congratulations to the whole team and great product. So in a nutshell, like it allows data interoperability, automation workflow and collaboration various among various software we have in AEC. So the best part open source, and that's what I really like about this whole development. And if you want to know more, let's review some docs. Oh, not secure. Hmm, okay. So I think it's important that we understand the architecture of this, how this whole platform works. And there's one diagram I wanted to show. So basically, whatever app or software you're using, let's say Revit or Rhino, all the geometry objects, they're converting into their own schema, which is then translated to another software. So that's how data, this is how data becomes interoperable, but you need to have some schema which can be, you know, converted into Speckle object, and when you are uh, again using it in another software, you need to reconvert that data schema into schema that software understands. So this is how they're mentioning Kit, where if you have a new software, you write a converter which converts that language into uh, Speckle data schema, and then if it's in Speckle data schema, you can use it in any of the software. And if you go deeper, so how are they? First, they're converting it and they're storing it in their, like the server. And before storing it on the server, they serialize and decompose the data. And serialization, what I could say is like we know data schema and we understand as human understands in the form of words and things, but it's 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 not like the most efficient way of storing data, transporting data, and reading. So you serialize it in binary form, and then you transport that data from on the web or various among software, and you deserialize it in the software you want to read it again or in the web. So one way I could say, like, let's say even on the website, you have like front end, and if the image is stored on backend, that image is transferred by converting that, serializing that image first, transporting from server to client, and in the client it deserializes, and then you read it, because ultimately it's binary data. I need to check if my audio has no issues, otherwise the whole live stream would be a challenge. Give me 1 second. Do. And this is like very like bidirectional, so if you have any questions and stuff, feel free to share it on the chat. We'll It's meant to learn together. So cool. So let's go deeper. We know converter, we know data schema, we know it serializes it, and then we have this transport. Hmm. How does this transport work? Different storage have various characteristics and employ a unique intermediate abstraction layer. Transport. Transport defines the way Speckle writes read from a given persistence layer. One such transport is Speckle's server transport. Oh, okay. So depending on your endpoint of your database storage solution, you can write that transport. Right, and reads and write your Speckle data in a location you specify. Well, does the same, but backend got it through as a local cache, so as to reduce the dependency on high latency stuff. Dang, they're doing some good uh, software engineering to make it very uh, to have good latency. Transport offers developers low level of flexibility in developing essentially their own custom backend to Speckle. Nice. Or pushing data to other system that can do different things, even as a whole. Ah, no restricted to single location. Speckle allows you to send data in parallel to multiple transport. Oh, that now this diagram makes sense. So you can send your data using this parallelized transport thing to multiple servers or multiple storage endpoints. Alternative plugin based on Speckle could be developed at X, more like a git writing at a local size next to a source file. This is whatever configuration you say, a local only usage of Speckle while pushing to remote being a secondary and optional operation. Oh, a lot of inspiration from how GitHub works. Pipe data from yep, data transportation efficiency. Use Speckle even without Speckle. Dang, man, this is super interesting. Ah, currently couple of in-memory SQLite disk remote MongoDB. It's NuGet, so for all the C# users, similarly as you install library in JavaScript, Python, in C#, you can download this NuGet library and use it. Imagine you write your own to use it. The only thing you need is to write a transportation that use your server API. You want to send your Okay, so how Is my API connected? Where are all the time? Hmm. Why are they requiring this too? Save object, transport, get object. Okay. Here's how. So this is the interface. Does that mean if I so using converter, I get into the data schema. And when I have the data schema, if I need to transport to my server or Speckle server, I use this transport. But where am I serializing it in first place? Hmm. So this is the, I think this is the API they are referring that you determine, you find your own source transport and then you expose it. They have a task. Hmm. All right. So I think this might be a good structure. So let's see. Converted, we talked about architecture. Okay, we can't talked about transportation. Let's discuss serialization. Nice. Hmm. Into a state that can be reconstructed. Perfect. The object graph gives it a meaning. Yep. In a new way would be large blob, which would be difficult and exclude. Or individual without deserializing the whole structure first. Database work best what we call flat. Yeah, so a blob, like I think like here, if you have like a heavy Revit model, if you convert that and serialize it, it would be very, very large blob in your memory. So to make it efficient, they are flattening it first. Solve the structural impedance means by deconstructing an object into individual constructive during the process of serialization. These individuals are then sent. Hmm, mm, 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 mm. Transported. So I think this is important. Like this is one big decision they have made where you can like let's say for example you can if you have like a graph database approach you can have like dependency of wall or like room wall furniture. So instead of having that they are flattening it out. And I'm curious how they are solving the dependency or relationship between one object with another. Hmm. Each object when serialized gets a unique ID which is generated by hashing its value. Okay, this is the hash. All objects are immutable even if they change through they'll get a new hash. Yep. These objects hashes are also used to assemble for each object. Its internal graph. Okay, yeah, that's what I like. Where is the graph references? What this means is each speckle object contains the information needed for reconstructing the graph. So they flatten it out And where is this tree created? And what? So they are decomposing the blob, or this is for reconstruction. Yeah, in order to decompose into like the original file and dependency, like this is the most important connection. Are they like how are they creating blob for deserialization? Or this blob is just like a geometry object? Or hmm, let's see. At the heart of Git, there are two types of trees and blobs. Blobs represent the file themselves. hmm Trees represent the file structure. Objects are essentially both a tree and a blob at the same time. The blob being the value of the object itself, and the tree represents its object graph. Okay. Does that mean each geometry object had its own blob, like wall, its own blob, or floor? Hmm. While Git sources its tree from the folder structure of a Speckle sources from the object graph itself. Hmm. How? Oh, okay. I see. Object graph. Okay, so the way Git manages it is like the how you structure the folder. Since we have all the object and its relationship, Speckle sources the tree from the object graph instead of like yeah, makes a lot of sense. The data can reside and make use of upsides of storage system. Relational database, but at the same time, those are not constrained as to how they structure it and can continue without working with another important uses JSON as a native serialization format for the object blobs. JSON is a yeah, yeah, decompose, wrapping up. Okay, to conclude about the architecture, you need Kit for data translation into Speckle object schema. You need serialization, then storage of it, and then retrieval. And that's why you need transport. New backend. Perfect. Thank. So we know the data workflow in the Speckle journey. Now let's go deeper. Direct. Hmm. Data hashing object kit. All right. Hashing speed correct now. What's the base object? Custom data structure that you want to transfer by Speckle should inherit it. Hmm. So I'm guessing when they say custom data structure, so we have like various, I would say like data structure for geometry, curves, all. So if you want to make my own custom data, like having that base is crucial. Dynamic object, this allows to be strongly typed when needed. Fall back elegantly on dynamic. Imagine a crossover between a JavaScript object and Ooh, it's quite cool. This removes some of the friction. Okay, get set to get the hash of this. But what are they referring by base? Like base geometry or this is the discriminator between assembly name and total children count. Yeah, so they have children. Dang. Yeah. Okay, base object as custom data. It's essentially a dynamic object at heart. Okay, you can set new properties. You can do that. But like, can for a project, how you determine what would be a base object? You can define singular object like this, like representing a built element, or you can define your own collection type based on new base. My commit Rhino layer equal to new list. So this new list is part of base method or layer B new list. Wait, is it referring to the type of base object? To the list of point. Rhino layer A to C new list string. Man, kind of confused here. Let's see. Hmm. Oh, okay. I think they are referring base as primitive types here. Of course, you can have custom classes that inherit from base. Yeah, define strongly typed properties in there, which can be accessed as usual. Point base class. Think this is what they are referring by dynamic. But how are all the bases of primitive types related to each other? Hmm. Inherent base class for their object. This ensures Speckle will be able to transport them. Oh, I see. Maybe it's for if all the object defined as base, that's the only thing they are transporting there. Hmm. Wait, so they're looking into all the object types in all the software, getting their base and then transporting it. Like I think like so the converter needs to know all the base types. Detaching when defining your dynamic base, you can detach them by appending A to the. Why would I do that? Okay, reference to another. Oh, they are answering the same question. Since it's possible to nest your base inherit class objects, detaching that may be assigned to object used by another keeps it data. Oh, okay. So they are having this storage efficiency. Makes sense. Detaching when appropriate means faster sending and receiving. Okay. Reference versus making a new variable or Additional storage. Nice, nice. Man, but still, how are they forming that tree, an object graph? Mm, 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 mm. Hashing, I assume may or may not know object is immutable. So much vibe of blockchain here in IPFS storage. Immutable, blockchain is immutable. That means if you change the property of one, essentially it gets a whole new identity, whole new object. Yeah, same like even in GitHub, if you add one more new letter, it has a new CID or even a, I don't know if space adding just blank spaces also creates a new CID or what. But with unique hashes that are dependent on objects properties. As a developer, you don't need to care. Or else it takes care of correctly setting a hash. Maybe I should just use them. Geometry serialization tool. It's another purely cosmetic change. The hash is now stored in a field called ID. Why? Mostly it's clear. Okay, yeah. Object, their content hash is their ID. That should be used across all storage layers. And how many storage layers are there? Okay, what about operations that are dependent on hashes? Hmm, hmm. You rarely need the hash of an object before serializing. Mm, storage from somewhere. Only if object has previously serialized. Okay, makes sense. If you really need the before serializing, don't panic. You can still generate now the. Oh, this is their serialization tool. So by default, it will serialize and then create ID. But if you need before, as a developer, extra cost that you'll be incurring. All right, we are getting into decomposition. There are like 5 references I already got in this document about decomposition API. Let me finish this doc first. The Speckle objects kit. Yeah, we know that. So they have done the heavy lifting of getting all the kit from all the software, and kudos. Displaying ways. You may encounter certain common patterns when exploring data in your web viewer. The objects in our object kit with properties that we display them in our front end. Class definition. Public list mesh. Display value. Polyline. Bounding. Wait, how are they? Okay, so these are like some additional property of like bounding box with each base object. Dang. I'm still not understanding why you need to detach the property. Mesh objects that represent the geometry of this use students is a solid display value. Yeah, like each of the base object will have their properties. I can get and set properties. I can add more property because of their dynamic. Mhm. Okay, special property. Yeah, it's come for classes inheriting base. Okay, the display value can be used to provide a geometric representation. Beam types like what? Into non-beam application. No way of rendering these elements natively. Okay. The display value property represents a fallback that will automatically be used by application when receiving types without a native conversion. Hmm. Cool stuff. That represent the geometry of the. So they have a fallback if the new software which is retrieving this data doesn't have this, doesn't have a type to render. Oh, so wall might have a fallback geometry of just a surface or a volume if it's like from Revit to Rhino, and all the wall will be generic volumes, I guess. Hmm. I'm thinking if with what about the additional properties of material or anything which Revit has, can I still access in Rhino property panel? If we get time, we'll check that. The display property is expected to either an object inheriting base or a list of objects inheriting base. Or wait, was that the list they were mentioning before? You know, there were. So if it is list of base, okay, if it's a set of codes or wall, it could display a fallback for them too. I'm just thinking, what if there's a custom object base class which has curves, surface, and volume? Does the display value will have a fallback of the new software's primitives? Dang, how are they architecting that? Is it converted in all receiving applications? How will the rule is enforced for custom base object? And in theory, any type of inheriting base is, oh shit, dang, isn't enforced for custom base object. Mm, 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 mm. Simple. So what should one do if they have custom base object? Can they modify the display value to fallback? All right, question to be asked. Decomposition API. Mm-mm-mm. Blobs and trees. I think, oh man, I'm having an intuition. All my base object questions and tree will be, might be answered in this document. Design and consider mostly relational binomials linked to each other. Perfect. Despite this is no mechanical way of structuring. How do we relate to each other? It depends. Dang. This is where I think the assumptions will come into play. A site may have a normal building object. So wait, I earlier I was getting confused into there is like one big base object. Looks like when they were talking about it, each geometry or views or anything is a, there's no like master here, but in this document we'll get to know. For example, a site may contain one or more building objects, level, wall, floor, perfect. Converted may each individually reference the same site and there's wall and beams and each of them rather than being grouped under a level. They usually reference specific level. Okay, we have taken a good look how we get operates to okay, we know that uh, data structured in memory. An object is at the center both. Yeah. Dang. How are they solving the hierarchy? Decompose an object. There's no right or wrong way to design data. Provide with different models, different use cases, different hierarchy, different discipline. So mechanism by which specifying an object either via strongly typed kit or via dynamic properties, developers can decide what's get decomposed and what's not. Perfect. Let's see. It works in case of strongly typed binding, Speckle, specific attribute, detach property on the objects you want to store. Killed it. Now detach property and dynamic properties make some sense. Okay. Well, then within the object, for example, base building base object tells Speckle to store value of the site separately. Wait, are they referring separately means when they're doing flattening, is this like a separate flattened hash or this to store the value of the site separately? Okay, detach property, site, list of levels and owner. And then you go to level. This is the object type, height, base elevation. Then they have detached property of elements of wall and floor and columns on that floor. So I can say my site. So I'm accessing this and then say building A. Wait, where where are we defining building A here? Dang, okay. Mm-mm-mm. So each building can refer to that site. Mm-mm-mm. So building class has reference to site. Level class has reference to building. And elements have reference to level. But what if there is like half of the wall is in level 1 and half wall is in level 2 or the sloping thing? Mm-mm-mm. Any instant the site will be stored separately. Like where is this stored in memory? They must be doing some really good multi-threading GPU storage. I don't know, just guessing. If two buildings share the same site, it will be stored only once. Perfect. Oh, because it's reference, not another instance. Yep. And each instance of the building will hold ref. Okay, my bad. I should read before I start. Like it literally said the same thing I was thinking. Okay. Uh, in our example, each level can hold in a detachable property called pipes. Another, then each of this element will be individually accessible from the storage layer. But can you access the reference like among these elements from the storage level? But okay, you need a tree. If you have access to the tree, you have access to the hash ID. If you have access to the hash ID, you know the relationship. Ah, it's only will accessible. Why is this important? Let's imagine a building with a series of levels. The slab between this, the bottom or the top one. Good emoji. Dynamic detachment. Let's illustrate through this. So how dynamically added properties can be detached. Dang, detached word is very, I don't know, like kind of confusing. Like detach, you are adding it. So attach can be detached. Hmm. We assume we'll dynamically set top slab and bottom slab properties to each level in our imaginary object model. Here, 2 billion. Level 1, level 2. Slab between level 1. Level 1. Then why? Why? Hmm. I have this question. Why not just store one time? Like you're adding more properties to like bottom and top slab, and get you more storage. What does it mean? Okay, now maybe I got it. Since they know the slab is one object, but it refers to both level 1 and 2. They could have like strict property or not strict property or dynamic. And because they want to make it storage efficient, they added at the rate because now you just need to store this once. You can refer to both levels. It's a reference. But okay, so you store everything once, but you add dynamic property to various things as a reference. Hmm. Now detach. So when they say detach it, does it mean uh, it's what's it doing in the memory when you say detach it? Concurrently, one stored both level 1 will now hold a reference beyond storage efficiency. Java is only stored. This approach gives more freedom to structure data, however, it's best simultaneously query, slice, dice it however we need to. For example, let's assume you need to quantify takeoff. For each individual, specify the total surface area, including walls, ceiling, solution. Simply retrieve each level individually. So when I'm guessing when they're saying retrieve, each level I'll have access to all the elements, and when I get access to all the element, I can get access to the area. Goes total volume of concrete goes to slab. Solution, just query the building object of all this. But oh, so instead of querying level and then slab, just query all the slab object. Mm-mm-mm. So when, okay, total surface area, I need both top of slab and bottom of slab. That's why going to individual level makes sense. But I can also query all the objects directly and get their surface area. Why do I need to go to building level? Like each instance of wall, ceiling, I can retrieve that. Okay. Similarly, imagine you have written a script that does environmental analysis. Jungling to bring in the level above it to just gets the results are calculated. They can be stored in a detachable property on the span. Solar comfort with and later down then one could query all the wait. So you are using detachable property not only for storage efficiency, but also for but you querying. But if it's a property, you can query anything, right? Objects individually or if needed for the whole building. All right. Got maybe 60-70% of what they're trying to do with dynamic detachment. Decomposing object. So all the assumptions they have it in their converter, like what is being referenced, what is being stored as instance. Dang. Okay. So if you need a custom data structure or relationship, you gotta modify the converter then. Hmm. Decomposing of an object happens within without the surface and you ask to return. Okay. Oh, when they're saying blob, is it just like the base class or base object? Just storing in blob and you need a reference to deserialize. Okay, when they're deserializing, they also need the relationship. So they need the tree, and then you're there getting like a bigger blob or what for the original data schema. Recomposing parent object, inserting in place the reference of the actual reference. Yeah. So all the tree hash ID, imagine that being replaced with the blob with the deserialization. It's actually rather simple. And the end result is the decomposed object when we receive back will be identical with the original one. Yay! All parts. Man, so much engineering just to get from one model, one software to another. Problem. Beat up with many faces. Surfaceless probably. Hundreds of potentially have services. 100K. Oh my god. This is also in chunky memory heavy serialization can be answered. Dang. Before reading, I'm very excited for the solution. In order of, what is this? In order of preference. Wait, can I use Speckle for optimizing geometry and like reducing poly count or something? Hackathon idea I should do it in a lot of metaverse. We need optimizing geometry. Noted. Optimize the list so it's more lightweight so I can chunk the list property. Mm-hmm. List of vertices, most efficient ways. List double. Oh, because point will have its own vertices. Why not go to vertices itself? So storing each individual point you store in a typed array serial, but still you're storing 1,000 vertices. Second portion of the code. In some cases, you might be too lazy to actually optimize story. Come on, you're not lazy. Or it might be too convenient you to use the class. Alternatively, you might have a simple list table that expands to millions of items, like in the case of Barilla. In the cases above, the best way to mark them is chunkable together with detached property. This will tell you that it should split into manageable chunks of items, the size of which you can control. For what? However, chunk. What does chunkable is actually doing? Is it like a grouping? Wait, is the serialization like one time thing or like continuous? You know what I'm asking is like if it's like 1 GB of Revit file, is it like forming the graph and like sending 100 bytes to storage and then in 10 seconds do 1 GB, or it's like sending 1 GB of serialized data to the storage at once? Because if it's doing step by step, then chunkable is like one chunk go to storage or something. How chunkable is storing in database? All right. A detached property can be performance foot gun. Foot gun in some scenario. For example, if you have a list one that can grow real big and you mark it as a data without marking. Step. Oh, this is a crime. You can't do this. It's bad. It will take longer. I want a bad object model design. Maybe you guys should write some tips on good object model design. What is the most efficient way of storing data? And use structure the design data. And the powerful API on top of which can scaffold your digital automation. Where is that API? Store arbitrary data scaffold with Speckle without paying any penalty. Flatten. Okay, man. Updated last January. Oh, 8-1 last September or August. Kids were originally in the camera, but check out the original. You can check out how to. But let's understand. Rabbit conversion right now. Key tags. Yeah, I want to know their object model. Come on. Set up implement various authoring. Converts data into intermediate object. This is crucial. I want to know Speckle's object model. Kits are not tied to the core of Speckle. They're pluggable. Anyone can add how kit work. Use them to handle all element types, geometry, discipline, user. Wait, what was the previous iteration of Speckle? They were not handling all the types. Yeah. Not available. We're planning to add soon. You guys are already doing a lot of work. Take your time. When a connector needs to convert an object, it will only search for available conversion routines in selected object. Hmm. Let me check if there are any questions. See, why is mutant? Either only A or B. Otherwise, we might have to query things in level use more memory. Maybe. Good points. Yeah, Richa is mentioning some comments on YouTube. Ah, where are we? Convert into kids folder and wait, what is this random? Confused. I thought each converter was its own kit. Looks like they are packaging it with a kids folder. And what is connector? Okay, hang. So much documentation here. To do object is the name of our default chips with any of our convert connectors. Okay, kit is part of the connector. It's perfect base for any customization or extension. You can be object kit. We'll get there. Hang. This document was very high level. Yeah, so here you can read your own transport. Okay. Dumping data. Okay. Transport, storage, serialization. Whoa. We got it. This is good stuff. Same is a potential quite wasteful operation. Depending on the size of one of our goals, tools are very large without adding too much. Thank you guys. Why can it be spent on? Imagine you have a model of 100k building objects. Okay. To send that model to Speckle, we need to convert those objects into Speckle object using a converter, then serialize it to JSON format. And finally, transport this. Of course, this you cover three representation of this code. Oh, native Speckle instance. So your Revit model running in the background. Speckle object representation of the same geometry. Then JSON object representation, like serialized form of the same geometry. How that go? To reduce that memory overhead, Speckle now integrates serialization with writing objects to one or more persistent layers. Dang, guys, what is persistent layers? Speckle now integrates serialization with one or more wire transfer. Whenever an object finishes serialization, it's sent to a transport for storage. And ultimately, its string representation gets garbage collected, just like this. Oh, nice! Like we have knocked the garbage. I know, like I was doing some metal thing, and like even like in React, like garbage collect and dump is crucial, like to save some memory. So what they are doing here is an object finishes relay, whatever object it is, are they also sending the, yeah, ultimately we care about the string when we are sending to storage, right? So once you finish it serialize, just send it to storage, delete it, like garbage collected. So so now we only are serializing the next geometry we care about. But thing is, like, how are you, okay, you store in memory the tree hash ID, but you are only garbage collecting, wait, not the blob. They're just garbage collecting the JSON. Wait, JSON is the blob, right? Okay. The 2.0 API exposes lower to man for sending and serializing. In this one, we will look only at the send one. Yeah, this is how you create a new base object. You are detaching the column base object to wait, this column itself is a base object in that data schema, and then you have a list of column attached to this bigger base object. Is it that simple? Operations.send. So this one serializes it. My data together with detachable. So default Speckle default skill ID. And return the ID of my data, which can be used to retrieve it back again to the default Speckle local transfer. Oh, now it makes so much sense. Like earlier in the transport, they have like required in memory and required SQLite DB. They know they need those two by default transport because in the local memory of your PC, they're storing that database. So first you store it in SQLite DB, then you return the hash, then you send can use. Okay. More advanced. Yeah, that's what I was thinking. Your this is your geometry data or like base object data. Server. Imagine this one server. So this one is. So yeah. This is if you want to do like multiple transport at once. This is how you can set up your data store it in local, get the hash and blob, and this is how you can send that serialized data to multiple servers. Will persist with its detachable structure to all this transport when done returns object ID. Okay. Look at how simple it is. Wait, so this is JSON serialized. And this is Speckle's data object when you deserialize using the default SQL transport. No count, no extra. Wait, how? No accounts, no extra HTTP requests. This only for local operation. They're bound to single computer only. If you want to do this across local network, you can use or your own custom that stores data on a network accessible drive. For large collaborator, you can of course retrieve your data from the Speckle. Yeah. Mm, 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 mm. What do they mean by? So why would one need to store it on the drive? Yeah, so for example, every time someone commits on Speckle server, I need new geometry data. In order to update my application, I need to call this receive command, which syncs up, deserializes, and updates my geometry. But when I'm calling that, it's all the geometry deserialized geometry data in my local SQLite. But if I'm over a network drive, not everyone needs to store and call it locally, just one time. So good for collaboration. Makes sense. Send data to multiple places at the same time. You can't retrieve data from more places at the same time. Hence, receive only accept. Oh, yeah. This is tricky because if you send your data to 3 servers and one of the server makes changes when retrieving, you only read from one server because if there is no consistency or conflict among these 3 servers, Speckle data, your application will get confused. Oh man, okay. Advanced transfer. Send and receive function and the example above global cache. Located in Speckle. In case of send, this means the object will be written to SQLite transport that is used by Speckle always. Buffer to and from. Yeah, buffer is also. Wait, why is it buffer for temporary storage in memory? Like there's some use cases where you don't want to go for my projects. Oh, so if I just open my local folder, I could see all the commit instead of opening in browser in object storage. So when I sync up new commit, it goes to local and updates this object.db or what? Interesting. So you have your file. First you do send data. It makes up this. It updates this subject DB, reference DB, and in your memory, How is this correlated to this part? Oh, so once you fetch all the memory operations, you have the final thing you update at that time here. Hmm. How would you actually implement such? Customize the location of transfer. Specify for where actually. This is if you want to send your data to only two transport. Local. This is your local. Custom local. Oh. Oh. So maybe. Come on. This is default storage. And this could be new base path. Can take an optional use default cache for to bypass the global cache. And Speckle, we need a document on how you're managing global and local cache. Okay, send. Okay, we'll bypass the global cache. Okay. Wait, if you want to use custom local transport, remote transport, what is local custom local? This will Docker container. Memory transfer. Oh, so when they say it doesn't touch a disk, means like it won't store it on the disk and directly transport from the memory. Obviously, much faster. Hmm. I'm still confused how like, is local transport definition means overriding the default remote transport. Hmm. A lot of flexibility. How can you automating all the things, right? You're just sending and receiving data. Where are we automating? Customize workflow. Where and how you store data from the Speckle to one local or remote. Come on, we need some use cases. Thing, yeah, this is more kind of API access, personal access token. It will be also useful for your guest webhooks. Oh, we should talk about GraphQL Explorer. That is fun. Proof of key of code action. And this is another token scope is good. Who who can write stream, who can read stream. So maybe you can just have your client read access and your team write access. Now, I think the .NET is okay. Don't quote me on this. The .NET is more developed than their Python or Java SDK, but mm, 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 mm. So there is this core engine, Speckle Sharp repo. Together with it, you might find object or default kit. You can click motion core transport object converter. Hmm. How to use sending kit data. Okay. Hmm. If I wanted to write a particular geometry line in Excel, if any of you find an like reference on geometry line definition in Excel, let me know. That is one thing. Okay. Speckle.core.model. I building new base. Okay. The base class is from this. The base object like a dictionary. Nice. I'm using some Speckle Smart. What's Speckle Smart? Lets you organically compose your data. Dude, you should have mentioned this way before in architecture. Like especially the statement should be there in the base object. Let's see. Classes. Oh, okay. This. So each base detachable property, and that property could have classes. Yeah, this is where your building floor. What is this project? So they don't have any more classes. Like, hmm. So if you have BIM, like BEM, not BIM. So huh, how are they keeping it generic enough that BIM in tech? So this is not a converter. Converter will do that. Once we have like a BIM class, it's good time to check. Oh, for the fallback function. This is a good example. So okay, I mumbled a bit. So when I was mentioning about fallback, so remember like we had like the display value. So if let's say this beam goes in Rhino, Rhino doesn't have a class or like property type. So it goes to default mesh view. So this is like the fall. I guess this is the fallback. So beam has a curve line. The mesh is a detachable property. Why? Isn't it part of beam? I don't know. Schema. Schema is create a speckle beam beams. Oh, so yeah, by default, this is why you need documentation and codable. So this is my understanding, and I'm nowhere expert, but this is where they are hard coding the assumption that beam is of type structure. Baseline. This one ignore and so wait, they're losing a lot of data here because if I'm just getting a beam and just storing baseline and mesh, what about? Oh, I should have more patience here. So here, so they're getting kits model and if you're getting from Rabbit Beam, it has family type. Okay, they're not losing parameters. They have element ID, level ID. So these are the only properties which we are which this converter is storing and carrying for the beam object. Yeah, this dot family. And how? So from Revit, I'm getting all this data when I'm exporting my BIM. I'm storing this data here. These properties can be accessed in BIM. And yeah, definitely I was assuming Tekla is a structural software, so they have much more property about material, rebar, volume. Wait, Revit doesn't give volume or area. Bad. So this spiral beam. Oh, they had to add special class for this. Yeah. So namespace. So if you're getting from this particular type and okay, objects dot build element. This is default. Interesting. Ah, so wait, where are they using that So this is not like a very heavy mesh, but I was expecting. So at one point they mentioned they don't store point directly. They convert it into float double integer and store the vertices. Let's check that if they are doing it in mesh or it's the floor. Floor has a lot of vertices. Do structural slope direction. Hmm. Hmm. Wait, so where are they doing chunkable things and stuff they mentioned? Hmm, hmm, hmm. Mm. Huh. So these are the various base type and each has its own class and this is built element, basic geometry primitive. Yep. So this is a line. Oh, got it. Hmm. So we were when we were accessing the class. Okay, let me just confirm with if what I'm thinking and they're doing the right thing. Okay. This is a bounding box which we saw in the documentation. Huh. Nah, no, I was wrong. So what I was hoping is they were referring to line or mesh, and this mesh has chunkable. I was right. Yep. Yeah. So class to geometry type, and here, like it's where they are doing this. This is their assumption. Oh wait, 31250 hard coded. Cool. Dang. Mesh list. These are the properties. What is this JSON ignore? I, like it's evident there might be ignoring. What is count? What is that? Dividing by 3? Why? List a point. What is going to Speckle exception? List a point. Get texture coordinate. Faces.com. Align. Hmm. Mm-mm. Why do they need to do this? Anyways, so we have this geometry types. We have build element, which is composed of various geometry types. And what is this other? AutoCAD people. No, I don't know. Yeah, okay. Yeah, makes sense. Oh, even text is not a default. Text is composed of your lines. And wait, there's no default system.text. I was thinking there is a text default. No? Hmm. Okay. Primitive. What is this interval? All right. So we are structural analysis. Interfaces. Hmm. I think getting some idea. Oh, so this is our default object kit and it needs reference to all this. So we define this. So now we can use this. Speckle kit default. Wait, the reason we have kit is we need to have converter and if it stores that application into the native geometry types of that application into Speckle geometry types and class and base, which you can use with a transport for serialization. All right. Hmm. Converters. Where are we getting this converter? Variable list dictionary. So base object is a dictionary. Get available converters. Dang. Active loaded. Okay, I need to check. iSpeckle converter, load converter. Check it. Connector grasshopper. Connector CSI. Connector autos. Okay. So each application will have its own converter, which makes sense. This is for it. Connector Rabbit. Receive and send. Okay. I wanna see where defining core. I'm guessing this could be the one. Kit declaration. No. Speckle core kit. I spec. Nope. Load converter. Wait, I need where they are defining converter, right? Test kit. No, it won't be in load converter. Util. I think it might be in utils. I want to see a grasshopper. Connect grasshopper speckle sharp. So the connector. Let's go here. So this is a grasshopper connector. Okay. So example 5. Okay, this is how to use it. What is there in the utils? Okay, assembly info. And we have connect grasshopper. I want to see how conversion is happening. Boom, serialize. Nice. So this is getting into core. Love it. So when we are doing, so I need to define your GUID. Just give me how do I how it's converting a line into a serialized object. That's the minimum I want to understand. Path target index. So then to native to spec. So okay, so so stage 1 is from native to speckle, from speckle to serialization, then you send it, then you deserialize, then you do from speckle to native, whatever application it is. Okay, but it's a task. Okay, I want like that load converter. Like, how do you define that converter? Instance. Man, how much time to spend to build this speckle? It's incredible. Oh man, not helping. Ah, loader. Okay. I'm guessing this is where two native converter should play a big role because we need that grasshopper canvas created in speckle menu. Wait, is this more about the plugin? This is not I'm looking for. Tabs menu. Sure. Come on. Let's see. Create speckle object. This could be interesting. Connector grasshopper dot object. So we need Rhino grasshopper object to create speckle object by key value. Oh, this is what base key value dictionary type we are discussing for base. So object new GUID. Come on, give me some. Oh, this is where the trees. Come on. Get data list, get data tree. Okay. But how am IGH data access? So DA is Where am I sending my D solids? Okay, task. Oh, dude, this is really cool. So for each data tree or data list item, ta- that creating a task where run this, do the work of giving me keys and value tree of each object, then return. Just okay, do work. What is the work they're doing? Grasshopper. Value T, GH path, utilities. Oh, now we are talking. So this is where, okay, I should not get excited first. Let me check whether I found the right thing. So created the base object. So right now we are in Grasshopper. We are creating a Speckle object and path exists. They're checking the local path of Speckle value tree. Hold on. If so they need a list and converter not equal to Speckle object key utilities dot try convert item. This is what I was looking for. So each it's a list key and type from each key they want to convert into. So oh, okay. I won't comment why they're doing it, but okay. So we have each key. So each object has its own key, and each key is being tied with uh come on. This should return a hash of that object. So list converter key branch. Dang, we got a tree of values. Why do they have goo? Okay, I don't know. What's the there should be some history behind this. Okay, time for Dynamo. This is extra. This is not extra. This is the main utility I wanted. Okay, try convert item into Speckle. That item can be anything. So give me the value. Give me the converter. So I get my reference ID. Get value dot get type get property value get lots of thing going on. Simple type convert. If convert this is true, convert to Speckle. Result dot application of ready. Yeah, that's what I was thinking. Gives me that ID. Is subclass type of so if subclass is true, transforms to dynamic props only. Ooh, okay. Because a bit try and convert the Speckle. Dang, how are they parsing all this in this tree and converting? Geometry. Oh, nice. So get ref ID. I saw it somewhere. Get. So first we call this converter. We get this ref ID, and what this ref ID is doing is checking what's the value we are giving. Where am I getting this value? So each grasshopper object get the value of it and send the value to determine whether it's a brep mesh line point. If it's a brep or case if it's ref, then it's checking whether it's a reference geometry or not. So if it's a reference geometry, r dot reference geometry to string. Wait, but how am I switch value? So all these values will fall into this and ref ID. Okay, what is this? Come on. So I just want to see if this is not the content hash, or is this a content hash? Okay, converter is null, can convert to native base data and cannot do uh, this convert to tree. So they are getting blobs in tree, and the tree object graph gives the tree. Oh man, now I am a bit lost here. We've been speaking for 2 hours. Let me get some water. Okay, where were we? No, not here. So I'm kind of getting an intuitive feeling about how it's working. Oh yeah. So once we get the value, where's this converter? Oh, okay. Can convert to Speckle. This converter. Okay. Git manager. I think we need like part 2 for this. So yeah, stream URL using data couldn't be there using our SDK. Advanced reselling suite. Ooh, this is very easy. Speckle API, Speckle model, data. Default cache. Okay. Without a manager. Nice. If I have the personal client stream. So maybe let's wrap up with this and then we can have part two. Flattens any base object instead of constituted path. Returns a list of sub base. Add this to project somewhere and you're good to go. Somewhere and you're good to go. That's an extension. Get dynamic member names for each. Ooh. Nested. So we'll flatten it. Oh man. So how is this child? Forward child nested return child. Okay. Just wanted to know. I thought this is where they'll form like tree relationship and store tree, but need to know this function. Let's query the data. This is how you getting the stream, flattening the data, and to list flat data, find all object. Oh, this is very cool. Maybe that's why they have SQLite and this kind of relationship. Makes sense. You can also categorize. Oh, if you can categorize, I don't know if that viewer can do filter. Cool. How do I set a filter? Ah, interesting. Nice. So is this being done on the client? Yeah, obviously. Huh. Hmm. Good viewer. Okay. Let's extract all the rooms. Okay. Dang, then I'm confused. Like if I can do all this relational query even on this flattened data, when would a graph data structure make sense? Or they are all actually it doesn't, like we are filtering it by category. Unless we can directly go to the base object, yeah, and query which levels and after level column on that level. Hmm. For complex query, let's create a summary. Ooh, these guys are reading my mind. And a lot of, yeah, this is like level name. And what is a link? Okay. Conclusion: structured data was much more needed. Both have advantages and disadvantages. The later lends itself for ETL workflows and various classification based exercises, where the former allows for better model. Dealing with structured data doesn't mean that we can't flatten it and benefit from all the processing ease of flatten. You can use this as a basis for acquired few automate compiling bill of material model quality. Like there are what's ETL workflows? Extraction of data from the source, cleaning, transformation, loading into target data warehouse, schema of source. Hmm. Whew. Nice. Object geometry built. Oh, that's what I discovered on the GitHub. In read mode of the basics class, there are few object can inherit from, including ICO. Okay. The class itself need to have an empty constructor for Oh, phew. This is big thing. Can create as additional constructor for your own use as makes sense. The class has empty construct. Okay. Well, class the extent basic. The series of default Revit properties. This is how we for specific host application object native object. Perfect. Yep. At least one constructor with that good schema info. Human readable. Hmm, okay. Yeah. Need to read more about the schema depreciated to the converter. Whoa, this is what I was. Detail code Speckle location to Speckle. Cat element. Convert and cache. Can write. Telemetry. This is so cool. Um, get transport. All right, I think there's a lot. I I'll have some maybe hands-on activity for next time. I got some intuitive understanding. See you. Thanks anyway, everyone who watched it, and please share your feedback. How to make it like more collaborative, and see you.